All right, we got some reverse matrix multiplication here. So instead of solving for matrix A times matrix B, we're trying to solve for matrix B. So what I did first is I set up my matrix multiplication by setting A times the blank matrix B equals AB. So what I go through here, and I'm going to label each piece of matrix B because we need to solve for 4 different things here. So I'm going to label the elements B11, B12, B21, and B22. Remembering the rows come first, then the columns. So this first one is row 1, column 1 element for B. Then we can go through the process of doing matrix multiplication. So what I like to do is this one right here. To get 14, well, that would be row 1 of A times row 1 or column 1 of B. So we got this one times this first column. Putting them together, that would be 4 times B11 plus, minus 1 times B21. Then let's go ahead and do the next bit. We're looking at, let's do this one. All right, so now we're looking at row 2, and then let's do column 1 again so that we're looking at the same 2 variables. So that is solving for this piece right here because it's row 2, column 1. So 2 B11 plus 3 times B21. And now that we have that, we can build the other ones. So going back over here, looking at 19, well, that would be row 1, column 2. So it'd be 4 times B12 plus, no, minus again, minus 1 times B22 equals 19. I forgot to do that for these other ones. So this one right here equaled 14, and this one equaled negative 14. All right, and we can go through and do the last one really quick. That's going to be 2 and 3, and then B12, B22, and then equals the last one, 13. What's really nice about these is like once you do the first 2, you kind of know what the second 2 are going to look like, as long as you're doing like the same 2 variables and chunking it like I did here. So the reason I went through and I chunked this is because in order to solve for B11 and B21, we can use these two. We can use these 2 equations. We have a systems of equations here. We could do substitution, we could do elimination, or we can use what we know about matrices. So I'm going to take these 2 right here, turn it into an augmented matrix using those coefficients. So I got 4, negative 1, and then 14. I've got 2, 3, and then negative 14. At this point, what I would do is I would go to my calculator and I type in my matrix, plug it all in. I can make a video of how to do that on the TI-84, or you can do your regular elimination and row operations to solve. But I think it's easiest just to do your RREF in the calculator, and we end up with 102, 0, 1, negative 6. So it just solves it for us. That means that since I put B11 here and B21 here, that means that B11 equals 2 and B21 equals negative 6. And we're halfway there. So we'll do the same thing, take these ones, make an augmented matrix, 4, negative 1, 19, 2, 3, 13. Go to the calculator, plug in your matrix, go back, do the RREF, and we get 1, 0, 5, 0, 1, 1. Right now we can see that our B 1, 2 is equal to 5, and our B22 is equal to 1. Final answer, B equals. Put all of them back in the correct spots. That's also why I labeled them the way I did, because I know B11